Okay, so far we have defined what a half-life is. I've kind of given you a really good example of how half-lives work using money. Remember, a half-life is just whatever amount of time. In our other example, it was 1 year. It takes for the material to be cut in half. Every time we divide by 2, cut it in half, we've gone through a half-life. So now let's kind of apply that to atoms. Now, I know this is kind of hard to see on page 33. That's why I put it here if you want to pause so that you can kind of look at it, redraw it, feel free. But we're going to use this to kind of help us visualize, once again, what we're actually saying. So you can see, just like in the drawing that I gave you guys over here, I just use squares. They're just using our graph, okay? So at 0, okay, in other words, no years have passed. This is the year that this substance was here, and in this case, we're using carbon-14. We have all of it, 100%. You notice, guess what? It's all blue, okay? Now, it wants to know how long is a half-life of carbon-14. Well, basically, it wants to know how long does it take to cut the material in half. So I'm going to come over here to my graph, and well, one half-life obviously would be the number 1. So how many years did it go through? 5,730. So the half-life of carbon is 5,730 years. Okay? Now, if you're having trouble seeing that, you can kind of see, look at my little pie graph here. Started, it was completely colored, it was whole. It was cut in half, okay, at 5,730 years. It means every time it goes through a half-life, 5,730 years pass. Okay? So let's get to a little bit more higher order questions here. If only 25% of the carbon-14 remains, how old is the material containing the carbon-14? You're like, whoa. There's no percentages over there. I don't know what you're talking about. Remember that picture that I showed you guys that I drew and I used percentages? So, year 0 is 100%. If I cut it in half, I have how much of the material? 50%. So that's one half-life. So if I cut it in half again, what percentage of the material do I have? 25%. So no matter what the substance is, if it goes through 2 half-lives, it's only going to have 25% remaining. So let's go back to our graph here. And we know 25% now is 2 half-lives. So let's read our graph. 1 half-life, 2 half-life. Or if that confuses you, look at your circle again. How much is left shaded? 25%, because we know this is 4 pieces, right? So 1/4 is 25%. So how many years have passed in 2 half-lives? Okay, 11,460 years. Oops. All right. I'm going to take that out. So using the same graph, it says if a sample originally had 120 atoms of carbon-14, think of this as like your $1,000. This is what we're starting with. How many atoms will remain after 17,190 years? Well, what we need to do, the first step, and I'm going to write this here. Step 1. Actually, let me do it this way. Step 1 is always to find your number of half-lives. You have to find the number of half-lives first before you can do any math. Well, this time it's pretty simple because we can kind of go over here and look at the graph. I gave it to you. So it wants to know 17,190 years. Well, there's that number. How many half-lives have passed? 3. So we know 3 half-lives, have passed. So now, step 2 is going to be to divide our original amount in half the number of times we got in step 1. In other words, we're going to divide it in half the number of half-lives it's gone through. But I'm trying to simplify it for you so that you kind of can make sense. All right, so watch what I'm going to do. We started with 120 atoms. We learned that for it to go through for it to be 17,190 years old, it had to go through 3 half-lives. So this means we're going to divide 120 in half 3 times. So 120 divided by 2, which is 1 half-life, is 60. 60 divided by 2, which is 2 half-lives, equals 30. 30 divided by 2, which is 3 half-lives, which is what we're supposed to go through, equals 15. That means at the end of 3 half-lives, I only have 15 atoms of my 120 remaining. This is just like our $1,000 example. After 5 years, we only had $31 left when we started with 1,000. Here, we went through 3 half-lives. We started with 120. We divided it in half 3 times, giving us 15 atoms. Here's what I would like you guys to do, okay? You guys are going to try to do problem 7, 8, and 9. I'm going to have you guys pause it here. I really want you to pause it, and I want you to try these on your own. Now, I'm going to keep going, and I'm going to go over 7, 8, and 9, but I don't want you just to write down what I'm saying. I want you guys to think about what it's asking, try it on your own, and then come see how I did it, okay? So I am asking you to just pause the movie, not the movie, but the video right here. Take a second, try to see what you're doing, see if you can figure it out, and then come back, okay? Now, if you've already paused it and you're ready to move, I'm going to go ahead and kind of walk you through these. Now, for 7, 8, and 9, you're given a table that gives you the different types of isotopes and how long their half-life is. It's kind of crazy that uranium-238 has a 45 billion year half-life. Means 45 billion years we got to pass for that material to even go through 1 half-life. That's crazy, okay? So you can see some pretty interesting numbers there. So number 7 says, if a sample known to be about 11,460 years old has 400 carbon-14 atoms, how many atoms were in this sample when the organism died? Whoa, wait. How am I supposed to know? Well, we know how much is left. We want to know how much is started with. So for this problem, all we're going to do is reverse step 2. In other words, instead of dividing, we are going to multiply by 2. So let me show you what I mean by that. So step 1 says, find the number of half-lives, correct? Well, we're still doing carbon-14. So to make my life easier, I'm going to go back to that graph, okay? We know that it's been 11,460 years. So how many half-lives have passed? 2. So step 1 says we know that the half-life is 2. Now step 2 told us to take in whatever amount we've got, divide it that many times. But because we're wanting to know the original amount, so if we want to know the original amount, we reverse step 2. This means we multiply ever how many times our half-lives we had. So how many half-lives? 2. So we know we ended with 400 atoms. Now, because we're going backwards, this time we're going to multiply by 2. So after 1 half-life, we had 800 atoms of carbon. But we went through 2 half-lives. So we're going to multiply by 2 again. This time, we have 1,600 atoms. This means that before this actually got started, before 11,000 years passed, the original amount was 1,600. Okay? So anytime It's looking for the original amount. You do everything the same except for step 2. What is step 2 again? Divide our original amount in half the number of times we got in step 1. Here, we're only going to reverse it and we're going to multiply. Okay. By 2. Okay. Or multiply by 2. Let me be clear here. The number of times we got in step 1. Because remember, this half-life could be 3. That would just mean we multiply this number by 2 3 times. Okay? So let's do this one. Starting with 50 grams, and we're going to use that chart